Next, let's discuss indoor air pollution. Now, indoor air pollution is a term that usually is not associated with air pollution. Whenever we discuss air pollution, we discuss industries, we discuss automobile, we discuss thermal power plants, but we never discuss the kind of pollution that exists in our homes. So this is the kind of pollution that we are going to discuss here, and this is called as indoor air pollution. So have a look at this particular diagram. This is giving you an estimate to what kind of pollutants exist inside our homes. So you have carbon dioxide, you have carbon monoxide, benzene, you have PM 2.5 and PM 10, which is also a part of pollution that we have already seen. So all these kind of pollutants exist here. Even you have something called as formaldehyde, which comes from the furniture. So all these pollutants exist inside our homes. And if we talk about the health impacts that you can have due to air pollution inside, can be respiratory diseases and there can be other health effects as well. So the most common pollutants in urban interiors are cigarette smoke, gases from stoves, formaldehyde, pesticides, cleaning solvents and ozone. Apart from that, the pesticides, the mosquito repellents, cleaning agents, all these can also become toxic. Then the building materials such as asbestos or glass fiber, paint, glue, varnishes, all these are also health hazards. So they can cause irritation of the skin, they can cause respiratory illness, they can cause even cancer. So all these kind of ailments can be caused by indoor air pollution. Apart from that, organisms like virus, bacteria, fungi, dust mites, etc. also thrive in the ducts which are found in the office buildings. So indoor air pollution can also result in ailments like cold, influenza and upset stomach. The problem with these diseases is that even if you have these diseases, you may not think that this is attributed to indoor pollution. You may think that it is happening due to weather changes or other common ways in which these kind of diseases happen. Then indoor pollution can also cause irritation, nausea, depression, etc. and they are collectively called as sick building syndrome. Please remember this particular phrase, sick building syndrome, which is attributed to indoor air pollution. Now let's have a look at the scenario that we have for indoor air pollution in India. So according to WHO, the major sources of indoor pollution in India are firstly tobacco smoke and smoke from the use of solid fuels with inefficient and leaky cooking stoves. So these are the two major sources of indoor air pollution in India. Now the problem of indoor air pollution is also very, very severe. Annually we are looking at approximately 4 lakh to 20 lakh premature deaths which is happening due to indoor air pollution. And majority of these deaths are occurring in children who are under the age of 5 years, and this is happening due to acute respiratory infections. In rural areas, the pollution is taking a toll on the health of women, because you know, women who are using the traditional stuffs, they use wood, they use coal, they use animal dung. So these kind of fuel, the solid fuel that is being used, they give out a lot of smoke and dust and cause a huge amount of pollution. And actually it is said that it is similar to smoking 100 cigarettes a day, the amount of pollution that they cause. Many deaths in North India during the winters happen due to the fact that the doors and windows are closed, and because of that the poisonous smokes which can contain carbon monoxide, and as we saw, carbon monoxide can form carboxyl hemoglobin which would mix with the blood and it can lead to the death of a person. So even the problem of indoor air pollution cannot be neglected. It is said that approximately 50% of air pollution is actually indoor air pollution, and it's something that we completely ignore. We always talk about the industries, we talk about the automobiles, but we never talk about the pollution that is existing inside our homes. Especially the people in rural India have to be educated about the fact that the kinds of stuffs, the kind of burning material that is being used, the fuel that is being used for domestic purposes, they are causing a lot of pollution in their homes. So this is about indoor air pollution. Now with this we have come to the conclusion of the factors which are responsible for pollution, the effects that we see because of pollution, and the kinds of pollutants that we have, all the major pollutants, the sources of those pollutants, what kind of pollution they cause. All these things we have seen. We have seen outdoor pollution as well as indoor pollution. Now in the second part of this lecture, I am going to move into one of the areas which is actually being caused due to air pollution, and that is acid rain. So I'm not discussing ozone hole here, I'm not discussing greenhouse effect, I'm not discussing global warming. All these topics we will consider in a separate chapter of climate change, which will follow the chapter of air pollution. But acid rain we will cover here itself. So when we discuss acid rain, remember two very important chemicals. One, oxides of nitrogen, and second, sulfur dioxide. If you ever get asked what are the root causes or what are the basic chemicals which are involved in acid rain, just remember that it is nitrogen oxides as well as sulfur dioxide. These are the two major components of acid rain. Not major, I would say all the components of acid rain. So now when we say acid rain actually is not the best term to use. Rather we should use the term acid or acidic deposition. So in simple terms you can say that it is the rain that is acidic in nature due to the presence of certain pollutants in the air, which can be industrial, which can be due to automobiles. Also, it can be defined as rain, fog, sleet or snow that has been made acidic by the pollutants in the air as a result of fossil fuel and industrial combustion that mostly emit nitrogen oxides and sulfur dioxide. So when we say acidity or when we say acid rain, does that mean that it has to be slightly acidic and it would be called acid rain? Just a brief background. If we talk about pH level, what is this pH level? pH level is basically from 0 to 14, and if the pH reading is in the range of 0 to 7, it is called as acidic, and if it is from 7 to 14, it is called as basic. Right? So 0 to 7. 7 is where you call something as neutral, neither acidic nor basic. So the normal rainwater that we have, that does not have a pH of 7. It is not completely neutral. It is slightly acidic. Why is it slightly acidic? This is mainly because of presence of carbon dioxide. So the carbon dioxide that you have in the atmosphere, this reacts with water to form carbonic acid. What is this? This is carbonic acid. Carbonic acid is slightly acidic, so that's why rainwater normally has a pH range of 5.3 to 6. So if the pH range is below 5.3, in that case you can call it as acid rain. So it's not that it will be highly acidic and the pH level will be 2 or 1 or 3. No, that will not happen. Normally it will be in the range of, you can say, 4.3 up to 5.3, 5.4, etc. So still you can say that it is not highly acidic, it is slightly acidic, weakly acidic in nature. Correct? Then what happens is that when these gases that we have, sulfur dioxide, nitrogen oxides, etc., when they react with water or water droplets that are there in the atmosphere, formation of sulfuric acid or nitric acid happens. Sulfuric acid or nitric acid. And the formation of sulfuric acid and nitric acid is what causes acid rain. So this is what happens here. If you look at this particular diagram, you will get a fair knowledge of which are the areas that get affected by acid rain. So if you look at all these red areas, particular diagram, you will get a fair knowledge of sulfuric acid and nitric acid is what causes acid rain. So this is what happens here. If you look at this particular diagram, you will get a fair knowledge of which are the areas that get affected by acid rain. So if you look at all these red areas, these are the ones which have the problem of acid rain currently. Then all the yellow ones, if you look at this part of central India, These are the ones which have potential of becoming a problematic area. And then if you look at all the green areas, these are potential problem areas because of sensitive soil. So just remember all the red areas and the green areas. Apart from that, in India, there is a problem looming over central India of potential acid rain. Then, as we discussed, there are two forms of acid rain. One which is wet deposition and the other one which is dry deposition, and that's why I said that more than acid rain, a better term to use is acidic deposition rather than acid rain. So what is wet deposition? When the wind blows the acidic chemicals in the air to the areas where the weather is wet, the acids fall to the ground in form of rain, sleet, fog, snow or mist. Then dry deposition, when the wind blows the acidic chemicals in the air to the areas where the weather is dry. The acidic pollutants slip into dust or smoke and fall onto the ground as dry particles. These stick to the ground and other surfaces such as cars, houses, trees, buildings, etc. and remain there. So this is what we see as two forms of acid rain. So approximately 50% of the acidic pollutants in the atmosphere fall back through the dry deposition rather than wet deposition. And these acidic pollutants can be washed away from the earth's surface by rainstorms. So it was way back in 1800s when for the first time during Industrial Revolution, there was one chemist, Robert Angus Smith. Robert Angus Smith. He was the first one to discover the phenomena of acid rain in 1852 and the fact that there is a relationship between acid rain and atmospheric pollution in England. So in England he did his research and he found out these problems, right? So next let's have a look at what are the causes of acid rain. So causes can either be natural or the causes can be man-made. So both natural and man-made sources are known to play a role in the formation of acid rain. But mainly it is due to the combustion of fossil fuels which result in the emission of sulfur dioxide and nitrogen oxides that cause acid rain. So talking about the natural sources, the major agent for acid rain which is natural is volcanic emission. So volcanoes emit acid producing gases that create higher than normal amounts of acid rain or any other form of precipitation such as fog or snow, and up to an extent affect the vegetation cover and the health of the residents who are living in the surrounding areas. Apart from that, we have the decaying vegetation, wildfire and biological processes. So even you can take an example of dimethyl sulfide, which is a typical example of a biological contributor to the sulfur containing elements into the atmosphere. Apart from that, lightning strikes. Lightning strikes also naturally produce nitric oxides that react with water molecules via electrical activity and produce nitric acid, and therefore they also form acid rain. So these are the three natural causes of acid rain that we have. Then the second one are the causes which happen due to human activities. So here you have two major concerns. One, coal-fired electrical power generators, and second, automobiles. Now the man-made sources are primary contributors to acid rain. The sources such as let's say power generators, automobiles, etc. In particular, the use of coal in electrical power generation is the biggest contributor to the gaseous emissions that lead to acid rain. Now, automobiles and factories also release high amount of gaseous emissions on a daily basis. Now, the highly industrialized areas and urban regions which have large amount of traffic and have large amount of industrializations, they are the ones which suffer the most. The gases like sulfur dioxide and nitric oxide, they react with water and oxygen in the atmosphere and form chemicals like sulfuric acid, ammonium nitrate, nitric acid, all these things. And this is basically what leads to the acid rain. Now, the wind that we have, this carries these acidic compounds over large areas across borders, and then they fall back onto the ground in the form of acid rain and other kinds of precipitation. On reaching earth, it flows across the surface, absorbs into the soil, and enters into the lakes and rivers, and finally gets mixed up with seawater as well. If you talk about the gases such as sulfur dioxide or nitrogen oxides, these are primarily occurring from electrical power generators and burning of coal, which is responsible for acid rain. I'm repeating myself again and again, but you remember that these are the points which are important for you. Next, let's move on to this particular diagram, where you will get an idea of what exactly is happening. So you can have a look. You have these two sources, one coming from vehicles, one coming from factories. Both of them are giving nitric oxide, and from the industries you get sulfur dioxide and nitric oxide. They transform into sulfuric acid and nitric acid. Then they can either form the wet form of acidic deposition or the dry form of acidic deposition. So the dry acidic deposition can happen if there is no rain, and if it gets mixed with an area where you have the wet weather, in that case wet acidic deposition can happen, and this will come down in the form of acid rain. So you can see that it gets into the farms, it gets into the river bodies, it gets into the lakes. So the entire ecosystem is getting affected due to acid rain. Whether it is dry deposition or wet deposition, both are equally responsible for causing acid rain or causing problems in both on land as well as in the water. Now, one by one, we have classified all the effects of acid rain into different categories. So let's start with what kind of effect acid rain has on aquatic environment. So acid rain either falls directly on aquatic bodies or get run off the forest roads and fields to flow into streams, rivers and lakes. Then over a period of time, the acids get accumulated in the water and lower the overall pH of the water body. The aquatic plants and animals need particularly at least pH level of 4.8 to survive properly. Now, if the pH level falls, the conditions become hostile for the survival of aquatic life. So, acid rain has a tendency of altering the pH. So, this point is very important from that perspective. Then, if you look at this, if you have pH level below 5, most fish eggs cannot hatch. Lower pH can even kill the adult fish. Acid rain runoff from catchment areas into rivers and lakes has also reduced biodiversity as rivers and lakes become more and more acidic. So this is something which is a huge problem for us. Then what is the effect on forests? So first of all, it makes trees vulnerable to diseases. It is becoming vulnerable to extreme weather and insects by destroying their leaves, damaging the bark and arresting the growth of these trees. So the forest damage due to acid rain is most evident in Eastern Europe, especially Germany, Poland and Switzerland. So these are the three major countries which have gotten affected by acid rain. Next, let's have a look at what is the effect of acid rain on soil. Now, acid rain highly impacts the soil chemistry as well as soil biology. What it means is that the soil microbes and the biological activity as well as the soil chemical composition, like soil pH, they are either damaged or reversed due to the effects of acid rain. The soil needs to maintain an optimal pH level for the continuity of biological activity, such as you can say the action of microbes. So when the acids seep into the soil, it means that the soil pH is getting reduced, which may damage all the biological activities which is happening there. The microorganisms can be killed because of highly acidic nature of soil. Apart from that, many vital minerals of the soil can be leached away due to the action of hydrogen ions. So all these kind of effects can be seen due to acidic nature of the soil on plants as well as animals of the given region. Then the effect that it has on vegetation cover and the plantations. So if you look at these lines, the damaging effect of acid rain on soil and high level of dry deposition damage the high altitude forests and vegetation cover, since they are mostly encircled by acidic fogs and clouds. Stunted growth and even death of some of the forest and vegetation cover is highly likely in these kind of areas. So normally the vegetation cover and plantations, the key word is high altitude. Next, the effect that it has on architecture and buildings. So acid rain on buildings, especially those constructed with limestone, react with minerals and corrode them away. This leaves the buildings weak and susceptible to decay. Modern buildings, cars, airplanes, steel bridges, pipes are all affected by acid rain, and irrepressible damage can be caused to old heritage buildings. And this is very, very evident in the areas near Mathura refinery, that is the Taj Mahal in Agra, and also the buildings at Fatehpur Sikri. So these buildings, the monuments, have seen some kind of effect due to acid rain. There has been a lot of talk in and around Taj Mahal and the effect that Mathura refinery has on Taj Mahal due to acid rain. Then the effect on public health. So when they are in the atmosphere, sulfur dioxide, nitrogen oxides, the particulate matter, all these degrade the visibility and can cause accidents. So directly we are not talking about a health hazard, but we are indirectly talking about problems with public health. So public health is not directly affected by acid rain because acid rain water is too dilute to cause serious health problems. However, the dry depositions, also known as gaseous particulates in the air, which in this case are nitrogen oxides and sulfur dioxide, can cause serious health problems when inhaled. Intensified levels of acid deposition in dry form in the air can cause lung and heart problems such as bronchitis and asthma. And if you know the case, when we talk about our country India, we talk about juvenile asthma, which has been seen as a common problem due to air pollution, right? So indirectly, we are not talking about acid rain when we talk about juvenile asthma, but normally we are discussing air pollution and dry deposition. That's why indirectly acid rain. Then what are the other effects? First of all, it leads to weathering of buildings, corrosion of metals, peeling of paints on surfaces. Buildings and structures made of marble and limestone are the ones specially damaged by acid rain due to reactivity of the acids in the rain and calcium compounds in the structure. And that's why we are talking about marble. The effects are commonly seen on statues, old gravestones, historic monuments, and damaged buildings. Acid rain also corrodes metals like steel, bronze, copper, and iron. So these are some of the effects that we categorize these effects according to the bracket they belong to. Now, what are the solutions that we have for acid rain? So talking about the solutions, the first one is cleaning up exhaust pipes and smokestacks. So most of the electrical power supporting modern day energy requirements come from combusting fossil fuels, as we all know, such as oil, natural gas, coal, and this generates sulfur dioxide and nitrogen oxides. Now, the burning of coal largely accounts for sulfur dioxide and nitrogen oxides. So what can be done? First, washing the coal can be one of the solution. Then using coal with low sulfur amounts. Then apart from that, what else can we do? We can use scrubbers. What are scrubbers? So scrubbers or scrubbing, something that is also known as flue gas desulfurization, or in short terms FGD. This can be used. So it typically works to chemically eliminate sulfur dioxide from the gases, leaving the smokestacks. So this is one of the solutions that we can have, and it can actually remove up to 95% of sulfur dioxide there. And power plants can also shift to using kinds of coals which have lower amount of sulfur dioxide. So instead of using coal, natural gas can be thought of, so that sulfur amounts are very less. So these are some of the emissions reducing strategies that we can put in. Then apart from that, the nitrogen oxide emissions which come from automobiles or the combustion of fuels from automobiles, they can be mitigated upon by the use of catalytic converters. We can use catalytic converters. So catalytic converters are fixed on the exhaust pipe system to reduce the nitrogen oxide emission. Apart from that, use of petrol that has a cleaner combustion can also be one of the strategies to reduce the amount of nitrogen oxides. Then the second way can be restoring damaged environments. How exactly? First of all, the use of limestone or lime, a process such which is called as liming, is something that people can do to repair that damage that is caused by acid rain to the water bodies like lakes or rivers, etc. So adding lime to acidic surface water basically balances the acidity. So it's a process that has extensively been used, for instance, in European countries like Sweden, to keep the water pH level at an optimum level. But one shortcoming that we have with liming is that it has to be done repetitively, and that's why it becomes an expensive method. Apart from that, it is something which is a short-term solution at the expense of solving a broader challenge of nitrogen oxides and sulfur dioxide emission. But the fact is that it definitely helps to restore and allows the survival of aquatic life, and that's very, very important. Then the next way of looking at things is alternate energy sources. So besides the fossil fuels, there is a wide range of alternative energy sources that can generate electrical power. These can include wind energy, geothermal energy, solar energy, hydroelectricity, nuclear power, all these things that we discussed in the energy chapter of science and technology. They all are alternate sources of energy. Bioenergy can be used. Very recently, there was a news that SpiceJet is going to fly with a biodiesel which is coming out of Jatropha. So, if you remember Jatropha, we discussed in the energy chapter in science and tech, you can have a look there. Fuel cells can be used, natural gas, batteries that can also substitute the use of fossil fuels as cleaner energy source, they can be used. So basically the only solution that we have is the fact that you have to reduce the amount of fossil fuel and phase it out over a period of time. Then apart from that, there are some individual, national or international actions that can be taken. So we know that millions of people directly or indirectly are contributing to sulfur dioxide and nitrogen oxide emissions. So mitigation of this challenge requires individuals to be more informed about energy conservation, and the ways of reducing emission also has to be known. So very simple things like turning off lights or electrical appliances when they are not being used, use of public transport, use of energy efficient lighting appliances, use of, let's say, hybrid vehicles or those which have low nitrogen oxide emissions. All these are the things which can be done on an individual level so that we are able to reduce the amount of pollution. So all these kind of things can be seen as solutions to the menace of acid rain. So acid rain as a challenge does not pose a huge threat to India currently, but recently, a couple of years back, there was a report in Down to Earth magazine that now there is a threat looming over India as of acid rain which never existed. Acid rain basically was a problem of the West, of the European countries, of the USA. But now there are reports that there is a possibility of acid rain becoming a threat for India, especially the northern part of India and the central part of India. So this is where I'll end the lecture for this part, which is air pollution. Thank you very much.